Hello guys, welcome back to our class. Today we're going to be learning about multiplication. Our objectives of the day are: I can represent multiplication facts by using repeated addition, equal size groups, arrays, area models, equal jumps on a number line, and skip counting. Another objective is going to be: I can solve one-step problems involving multiplication. The first thing we're going to do is to learn the parts of the multiplication. Now, for example, we have this multiplication here. 4 times 7 equals 28. The 4 and the 7, we're going to call them factors. The factors are the two numbers you're going to be multiplying. Then we're going to have the answer to the problem. 4 times 7 is 28. So 28, we're going to call it the product. So the product is the answer of the multiplication. Now we have the symbol. Now I want you to notice that the multiplication symbol is basically the same as the addition symbol. If you notice, if I just rotate it a little bit, it's addition. And just I have to rotate it a little bit so it becomes an X, and this X is going to be the multiplication symbol. So this symbol, when you read it, you can say equal groups, represents equal groups. So when you read it, you say it like this: 4 groups of 7. So you say it's groups of. So again, you can tell 4 groups of 7 equals 28, or the other name is times. So you can read it like 4 times 7 equals 28. Because today we're going to be solving some multiplication problems, we need to know some of the important vocabulary that is going to signal to us that we're doing multiplication. So some of the words that tell us we have to multiply is obviously the word multiply, times, factors, product, multiple, area, groups of, equal groups, twice, double, triple, and in all. If you notice, for example, the word in all is very similar to when you are doing addition. And there's one word that could be a little bit tricky, because if you see the word each, but it's, and they tell you how much they have in each group, that means it's going to be multiplication. Let's read today's problem. Today's problem says Genesis has 3 baskets. Each basket has 9 apples. How many apples does she have in all? So the first thing I'm going to do is underline my question. How many apples does she have in all? And remember, to write the answer statement, I need to cross the words that make the question, because I don't need to use the question in an answer, the statement. Then I'm going to eliminate the auxiliary verb does. And then the words I have left are apples, she, have, in all. Now I know she is Genesis, and I always start with my noun. So I'm going to put here Genesis. Instead of have, I'm going to put has, because the auxiliary verb does is going to modify the verb. Genesis has blank apples in all. So that's my answer statement, and that's what I need to figure out today. Using the vocabulary we just learned, I'm going to find that this is a multiplication problem, and I know it because here says that I have in each basket, I have 9 apples. So this time they're telling me how many are in each group. Because they're telling me, I know this is going to tell me this is multiplication. And the other word that I have here is in all. So the word in all is included here. So that's two words that are telling me that this is a multiplication problem. So let's solve this problem together. The first representation we're going to do is equal groups. So Genesis has 3 baskets. So these plates are going to represent the 3 baskets that she has. Then here says that each basket has 9 apples. So these beads are going to represent the 9 apples in the first basket, 9 apples in the second basket, and 9 apples in the third basket. Now, if we count them, we can find out how many she has in all. So I know that she has, this is group 1, This is group 2, and this is group 3. And I know that she has 9 apples here, 9 apples here, and 9 apples on each basket. So if I take the baskets away, what I have left is what I call repeated addition, because I'm going to add 9 plus 9 plus 9, and I'm going to do now what I call a repeated addition. So this is going to become repeated addition. And I'm going to do partial additions. 9 plus 9 is 18, and 18 plus 9 is 27. So the answer is going to be 27. Now at this moment we did 2 representations. One that is called equal groups. So when you draw the groups and you count them, 9 plus 9, 18, plus 9, 27. Or you can represent the same problem using repeated addition, 9 plus 9, 18, and 18 plus 9, 27. Let's see a different representation. Let's solve the same problem, but this time we're going to be using a number line. So we know that we start in 0. And here says that Genesis has 3 baskets. So the 3 baskets are going to be 3 jumps. This is going to represent 1 basket. This is going to be basket number 2. So this is 2 baskets. And the last one is going to be the 3 baskets. Now I know that each basket has 9 apples. So the first jump is going to represent the 9 that has the first basket. So when I jump from 0 to I jump the first basket, is going to be a jump of 9. So I have 9. If I jump again 9, it's going to be 18. And if I jump one more basket, it's going to be 27. So this is how you represent it. Now that's going to be the same as if we do skip counting. So when we do skip counting, it's like counting in my number line the same number. So I start in 0, and then I go to 9, plus 9, 18, and plus 9, 27. So I skip count by 9s. So this is 1 time, this is 2 times, and this is 3 times. The next representation is called bar model. And bar model is very similar to the groups, the equal groups we did. But in this case, instead of represented with pictures or objects, we're going to represent it with bars. So this is going to be basket 1, basket 2, and basket 3. And all together they have this bar model. Now, the only thing we need to do is to make sure that we are telling how much is on each. I know this is basket 1, so it's going to be group 1, and this one has 9 apples. The next basket has 9 apples again, and the last basket has 9 apples too. So each of them has 9, and these are going to be the parts. So this is going to be part. This part has 9 apples. This part has 9 apples. So this is a part equals 9. This is another part equals 9. And it's another part that equals 9 too. But in multiplication, we're trying to find the whole. So in multiplication, we don't know the whole. And when we add again, 9 plus 9 plus 9, we're going to find out that the answer is 27. So for that case, we're going to use the multiplication. 3 groups of 9 equals 27. So this is going to be called the algorithm. You are going to know it too as a number sentence. The next representation is called array. The array is going to represent the 3 groups of 9 that equals 27. So I'm going to get like the apples, and I'm going to do this. It's going to be group number 1, and it's going to have 9. The thing about the array is that you have to make a kind of a rectangle and make sure all the pieces are really well aligned. So I have one group, so this is going to be group 1. group 1, and has 9. So if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, I have 9 here. Then I'm going to go with the second basket, or the group number 2. So I'm going to write here group 2. And then I'm going to align them and make sure I have 9 too. 4, 5, 6, 7, 8, and 9. So if I have 9 here plus 9 here, now I have 18. And then I'm going to do the basket number 3, which is going to be my group number 3. And then I'm going to align again the 9 apples, or the 9 objects that I have. 2, 3, 4, 5, 6, 7, 8, and 9. Now, if you count them from 18, 19, 20, 21, 22, 23, 24, 25, 26, and 27. So my answer is going to be again 27. Now you can find the multiplication here, because if you notice carefully, I have 3 here, so I do 1, 2, 3 times 1, 2, 3, 4, 5, 6, 7, 8, and 9. So the multiplication again is 3 times 9 equals 27. Now let's do the last representation for this problem. The last representation is called area model. And if you notice, it's very similar to the one we did before, which is the array. Now, the only difference is that this is going to be represented for squares that are going to be covering an area. That's why it's called area model. And then you're going to do the same. You're going to number how many you have in the side, how many groups do you have. And then if you notice, you have group number 1, group number 2, and group number 3. They are going to multiply it by how many are on each row. Each of these is called a row. So in row 1, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to put 9 again here. And you can put the numbers here, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So the multiplication again is going to be 3 times, or 3 groups of 9. And then we keep counting. This is 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And then 9 more. 19, 20, 21, 22, 23, 24, 25, 26, and 27. So the answer is still 27. If you remember, all the representations we did have the same answer. So I can write now the answer to my problem. Genesis has, oops, I have a mistake here, it's 27. Let me just fix it. Genesis has 27 apples in all. So I hope that you understood really well the multiplication and all the different representations. We're going to go, but before going, I'm going to show you your challenge for today. So your job is to solve this problem. One has 5 boxes. Each box has 6 toy cars. How many toy cars does he have in all? Now, these are all the representations you have to use to solve this problem. Repeated addition, skip counting, bar model, equal groups, skip counting in number line, area model, and array. So make sure you write your answer statement and you prove your answer well. See you next time, guys. Bye.